Participants after the lunch break. So we are ongoing with the session 2 of the day 2 with the topic of the applications of nanotechnology in the geotechnical engineering. This will be presented by Dr. Siddharth Shah. Dr. Siddharth is currently working as a professor and head of civil engineering department at Marwadi Education Foundation Group of Institution, Rajkot. Sir has completed his PhD from SPNIT Surat. He has total experience of about 17 years in the field of academia. His area of interest are soil structure interaction, use of plastic waste in improving the soil bearing capacity, use of plastic waste as geocell in pavement repair, applications of nanomaterial in civil engineering, and use of waste material in concrete for its improvement. Sir has published 29 research papers in journals and book chapters. In addition to the same, he has published 7 technical books and has attended 20 national and international conferences. Sir has guided 30 MTech students and currently 7 students are undergoing PhD under his guidance. Sir is also a lifetime member of Indian Geotechnical Society and Indian Society of Technical Education. So with this, we welcome you, sir, and we will enjoy the session. We hope we will enjoy the session and take up all the new informations which will be delivered by you.
Thank you, Saraswati, for your kind words and my introduction. So, good afternoon, all the participants. It's very tough time, to conduct lecture after post lunch session. But anyway, we are self-finance institute faculty, so we know how to take you to this ride, right? And let me share my screen first of all. Okay. I hope my screen is visible to everyone.
Sir, your screen is visible, but I think it is on not on the title slide. It is on the slide number 13.
Okay. Now I guess it is.
Yes,
on the first
it is now. It is on the title slide.
Okay. So, very good afternoon to all learners of this 5 days faculty development program, Emerging Trends in Geotechnical Engineering, organized by CHARUSAT, NMS Patel Department of Civil Engineering. Myself, Siddharth Shah. I am professor and head of Civil Engineering Department handling PG programs at Marwadi University, Rajkot. So this is my university, a very beautiful campus in the western part of the Gujarat and Rajkot. We are a state private university and we offer many engineering, business administration, computer applications, science, arts, commerce, physiotherapy, and all sorts of program. At particular civil engineering department, we offer undergraduate, postgraduate, and diploma as well as PhD studies. So before we start, because I am showing here lots of video and images, there might be some copyright protection, and our friends at CHARUSAT are going to publish this video on YouTube. So we take this liberty and we respect all the copyright holders. I have tried to maintain the giving courtesy and due respect to the all copyright holders. But if by unknowingly, if I have missed someone, then because this is a non-commercial use, it will be okay from their end, right? So the outline of my presentation is in this way, that first of all, we introduce what is nanotechnology. Then we'll discuss about what are various types of nanomaterial and what are their physical properties available. Then what is the application of the nanotechnology in civil engineering? And then we'll discuss what is the application of nanotechnology in geotechnical engineering. And then we'll conclude. So any action must have some outcome. So what are the tentative outcome of this lecture? So at the end of successful completion of this lecture, you would be able to understand what is nanotechnology, and you will also understand what are the various properties of different nanomaterials. So that is number one outcome. Number two outcome is that you will be able to analyze various nanomaterials available for the research, or you can manufacture them, and you might be able to select that okay, this material is good for this particular application and this material is good for that particular application. So you will be analyze the material and you would be able to select the appropriate material for a particular application. So we'll see that. So these are the two outcome of this lecture. Now everybody is aware of what is nano dimension. Nano means 10 raised to minus 9. It was inspired by the Greek word dwarf, which is the meaning of very small, tiny person. And 1 nanometer is obviously 1 billionth of a meter and 1 millionth of a millimeter. So let's see nano material. Nanotechnology means we are working at the scale of atom and subatoms. It's very minute. If we just take our hair and if you divide it in approximately 1 lakh pieces cross section, I'm talking, then probably you will reach at the nano level. And this was the great scientist Richard Feynman who realized that potential of this nanotechnology way back in 1959. This is 2021. So almost you can say 60 years back. 60 years back he had that vision, and he gave one sentence: there is plenty of room at bottom. So nanotechnology means going at down scale at bottom, and he was a visionary and he could realize various applications. So in history, in 1985, fluorescence was obtained, scanning and tunneling microscope were invented. Probably I was just of 4 years in 1985. And nanotechnology word was coined by Norio Taniguchi in 1974. Even I was not born. So that application has, that technology has risen up, and today we learn, we see so much of application of nanotechnology. So it is not like macro material that you directly add it into the cement or a soil and you do some work. So nanotechnology is very minute. So we have to go to the level of the atom and subatom, and then you may change the atomic characteristic or atomic arrangement of a particular material, and then it can act as a nanomaterial, and then the magic happens, right? So working at nanometer scale is very difficult. So let's see what is the size difference, and we require very sophisticated instrumentation like scanning electron microscope and tunneling electron microscope. So what is the size relevance? This is a typical our human hair. You must have seen this human hair in shampoo advertisements, right? There's so many layers, right? If we compare to the sand particle, it is very big, fine sand I am talking of, right? And if you compare this human hair in background of the some nanowires which are 1 nanometer or 2 nanometer thick, then our human hair is approximately 1 million times larger, 80,000 times large, right? So our human hair is 80,000 nanometer thick. Our red blood cell is approximately 5,000 nanometer. DNA is 2.5 nanometer wide, and 10 hydrogen atoms, if we arrange it side by side like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, side by side, then that width will be 1 nanometer. So atoms are so minute, so small. So again, we try to understand what the size is. So if we zoom 1,000 times the DNA, then we'll get one bacteria. If we magnify a bacteria by 1,000 times, then we'll get a raindrop. Similarly, there is a nanomaterial called carbon nanotube. If we zoom it, or if we multiply the zoom level by 1 lakh times, then probably we will get our human hair. And our human hair multiplied by 1 lakh times, then probably a 10-meter wide structure you can see. So that is the scale at which this technology has been evolved, right? So let us see how tiny it is. So these are the photograph of scanning electron microscope and tunneling electron microscope. So we have one video which will show us that how small the nano things are. So just hold on.
We have seen how nanotubes produced by arc discharge for deposition can be obtained on a
I hope my video screen is visible to everyone.
Yes, sir.
Okay. Audio also.
We have seen how
Yes, sir.
nanotubes produced by arc discharge are deposited on the cathode, but nanotubes produced by CVD or chemical vapor deposition can be obtained on a base. In this video we use electron microscopy to show how different those samples are at high magnification. But first let's look at them with the naked eye. Nicole is holding two samples, one produced by arc discharge and another one produced by CVD.
So carbon nanotube is produced by two methods. One is arc discharge and cathode deposition. So they are comparing that by which method the carbon nanotube is more purifiedly developed. But I am showing you this video that how scanning electron microscope work, how tunneling electron microscope work, and what image we get. Just like in 12th science, you might have used our chick cells or onion cell in a microscope. Similarly, you see how a nano dimension is there.
Remember we said that arc discharge doesn't produce great quantities, so guess which one is which? Let's go to Oxford and use their scanning electron microscope, or SEM, to have a closer look at the samples. First we need to put our sample in the holder for the SEM, and then Nicole puts the holder into the microscope. We can see the sample using a camera, which is inside the microscope. We need to set up the SEM, but with someone as experienced as Nicole this doesn't take long. This is the CVD sample at a lower magnification, but let's go to the highest possible magnification of the SEM. Now we can see the individual tubes. Let's change the sample and look at the arc discharge tubes. At low magnification we can see already that with arc discharge we have produced other forms as well as nanotubes. But let's zoom in to find individual tubes. And there they are. Let's go now to an even higher resolution microscope, the transmission electron microscope, or TEM. The resolution is higher, and also the microscope is bigger. It takes almost a whole room. Nicole puts our samples in an appropriate holder and introduces it into the microscope. Again, we need to set up the microscope before we take our images. These two images are an example from each sample. There you see how the arc discharge tubes are much more straight, more perfect, while the CVD tubes are more wavy because they have many more defects in their walls. I hope it's clear to see that the different production techniques produce samples of very different qualities with different structured nanotubes. Nicole gave me a great example. Nanotubes look like spaghetti. When they are produced by arc discharge they looked uncooked. When they are produced by CVD they look cooked.
My presentation is visible, I guess, now.
Yes, sir, it is.
Okay, so that is the magnification level possible with the these two microscopes, right? So we have scanning electron microscope, transmission electron microscope, atomic force microscope, nuclear magnetic resonance, crystallography, and so many things are there, right? Further, now how this microscope works, right? For that also I have one video, so let me show you that.
The Earth. Let's take a look at our planet on
Ça veut dire de le pousser.
between a meter and a billionth of a meter, roughly the same gulf, but taking just a few seconds. Now we're heading deep into the world of nanoscience, down to the dimension of an atom. To understand today's scientific nano-revolution, we must first take this plunge into a sea of atoms. New landscapes, new sensations. This hidden world surrounds us at all times, on every side. Each white ball is a cloud of electrons, concealing an atomic nucleus. You're about to discover how scientists have reached this frontier, the land of the atom, and opened up an infinite new field of research and practical applications.
On peut, comme premier axe, voir une miniaturisation de plus en plus poussée des composants d'une oreille qui ne marche plus. Et là, les conséquences.
Has already revolutionized
Forschung.
nanoparticles. Here are balls. Now this car door can't be for these phenomena, almost magical on our scale, is the shared property of all these objects, nanoparticles at the surface or inside. To understand how industry can manipulate these molecules on the nanoscale, we'll begin at the beginning. For the observation of particles no bigger than a few billionths of a meter, researchers invented a new microscope, only to discover that it could manipulate atoms too. With this tool, seeing is touching. Like a blind man's probing stick, the tip of the microscope feels the atoms to display their contours.
Ça représente une pointe avec idéalement un petit atome au bout. Et donc je vais approcher cette pointe de la surface.
So this is the principle how scanning electron microscope detects or shows that where is the surface irregularity or where is the electron cloud, right? Just see the video. Right now you will little surprise, or you might not get it, but you just see the video, automatically you will understand what they are trying to explain. Language is different. I think French.
Ici c'est la surface d'atome. On voit déjà d'ailleurs que le petit palpeur doit avoir à peu près les mêmes dimensions que les objets que l'on va regarder. Et on va déplacer cette pointe sur la surface, très très proche de la surface, pour enregistrer les interactions entre la pointe et la surface.
In this animated sequence, the tip, made up of atoms, is bathed in a blue glow, linking it to the surface observed. This glow represents an exchange of electrons between the surface atoms and those forming the tip. On this scale, the atoms can swap electrons. This is what happens as the tip of the microscope moves. With a scanning microscope such as this, pictures on the screen do not represent light, but rather computation. They are actually a measurement of electron flow voltage and intensity, changing with every movement across the measured atoms. This This provides a sort of relief map of the surface examined, atom by atom.
Cuando la distancia entre la punta y la muestra es del orden del nanómetro, se establece una corriente de electrones entre esa punta y esa muestra que no puede explicarse con los principios de la mecánica clásica de Newton. Solamente puede explicarse con los principios de la mecánica cuántica.
El principio básico es el que, básicamente, un principio de mecánica cuántica. La función de onda de la muestra.
Electrons in orbit. No surprises there. However, brace yourself for a shock. No scientist can say with certainty where an electron will be at any given moment. In fact, an electron doesn't revolve around a nucleus on a fixed orbit like a satellite around a planet. Instead, it may be at any point around the nucleus at any given time. It's as if it were everywhere at once, forming a sort of electronic cloud, a sphere in fact. This is one of the basic consequences of quantum physics. From time to time, an electron may happen to move a little further from its nucleus than usual. Since there's necessarily another atom close by on this scale, the electron sometimes finds itself in the cloud of electrons of this other atom, having broken through the barrier that held it around its own nucleus. This electron transfer is what we call the tunnel effect. It explains a large number of physical phenomena and finds an important application in the scanning tunneling microscope. For example, it can move them or tear them away. By generating a stronger electron flow through the tip of the microscope, a given atom can be attracted. This tool that can feel matter and thus give us an image can also sculpt it.
So nanotechnology is manipulating material at nano level. So with this principle, we can rearrange the atoms and subatoms. That's why they turned into the more systematic arrangement of atoms, and their physical properties are changed drastically. So we'll see that also. Just let us complete this video.
By gouging out atoms, it can etch lines or more complex patterns to build electronic circuits, for instance.
Y en esa fase estamos, intentando pues, crear lo que nosotros queremos, las figuras que nosotros queremos, la disposición atómica que nosotros queremos, para que en el futuro eso se pueda producir de manera industrial y pueda dibujar.
Computer memory capacity. In this a read-write head, just a few atoms thick. On this scale, the magnetic pole variations in each atom can be used to store encoded data. This has enabled hard disk capacity to be increased tenfold. Even so, competing systems on matter itself into reactions present.
Cette étape de synthèse, on en a introduit des milliards de.
Pushed by the tip of the tunnel effect microscope, it moves, rubbing against the surface. Successive images are needed to check that it has really been displaced. Mission accomplished. To make this movement more precise, researchers are trying to modify the initial structure of the molecule by adding paddle wheel extensions.
Ça joue le rôle un peu d'engrenage. Ça bute contre un atome et ça tourne.
Throughout Europe, scientists are working on many other types of nanorobot, which may be able to move hundreds of thousands of molecules at once, where the tip of the tunnel effect microscope can only handle one at a time, although other avenues are also being explored.
Au lieu d'avoir à fabriquer ces objets d'une qui est certain.
Universe and trying to reproduce deep.
How these chains for 60 carbon atoms.
By how these two atoms are connected to each other, how strongly they are connected. It's even strong.
Two pure carbon graphite electrodes connected to a DC generator in an atmosphere of helium, an inert gas that does not. Forming 90% of this powder, they are only visible through a microscope. This long structure.
So we have along this video. It is very interesting. So what I'll do is I will provide you the link of all these video in the chat box, right? So you can go through these videos later on also, but I request all of you to just go through this video because of the limitation of time I can't show you the entire video, right? But what I'm trying to convey is that the manipulation of material is possible at proton, neutron and electron level, right? So you have understood that how they are doing it. Okay, so this nanotechnology definition, thereby we can say that it is understanding, control and restructuring of matter on the order of the nanometer, right? And to create material with fundamentally new properties and function. For example, as one of the scientists explained that as we are working at proton and neutron level, so our gravity and Newtonian mechanics does not apply, but it is rules of the quantum mechanics, right? So electrostatic force take over the quantum effects and the proportion of the atoms on the surface increases relatively to those which are available inside, and because of these nano effects there are amazing properties. So you can understand, we can understand this, that compared to macro scale has a less surface area. So this figure very well explained that if we have a cube of 1 centimeter dimension, then surface area becomes 6. Now, if we divide that into 10 equal pieces on either sides, then we have surface area of 60 centimeters square. But if we divide them into 1 lakh sides on each side, then we have a how many zero, right? So probably 60 crore centimeters square surface area. So the material remains same, but the surface area increases, and as the surface area increases, their properties are changing. They are much more effective, right? So what novel properties are there? So for example, if we are arranging this atom together of the carbon and we make a carbon nanotube, then its tensile strength is amazingly increased and almost 150 times than that of the steel. Conductivity is increased, transmissibility is increased. In certain metal, even the physical form changes. For example, if we derive nano gold, then it becomes liquid. Certain inactive material become catalyst, right? Even silver, if we create a nano silver, then it gets antibacterial quantity. You might have heard there are a lot of, I think Samsung company has introduced way back silver nanotechnology for washing machines, right? And there are so many other applications. So with this video, we'll see what are other applications of nanomaterials, right? I hope new screen is visible.
Yes, sir.
So very first application is hydrophobic coating, right? So right part is coated and left part is not coated. So any material can be coated, right? This peripheral is coated, so liquid is not coming out. See our concrete shoots, right? Plastic sheet, anything can be coated, right? You see our concrete lab concrete mixer machine in our lab, if it is coated, it would be as clean as this. Right? Shoes, right? Nano fabrics are even available. It will not catch dirt. So you can see, as the title of the video says, that it will blow your mind. So lots of amazing applications are available, whether it is a bendable mobile screen, whether it is a smart fabric wherein doctor can remotely access the electronic cardiogram or sonographical images, right? So very wonderful applications are available. So just I have narrated few applications of nanotechnology in general. Lots of application in drugs and medical and environmental and consumer and foods, right? So lots of sewage treatment, right from tennis rackets, because earlier tennis rackets were very broken down, right? They were because of the stress concentration occurring at the junction. So now they have used this carbon fiber, and now tennis rackets are stronger. And likewise in drugs, nanobots, application for removing cholesterol blockage in the veins, everything is possible, right? And there are so many applications. I am not master of this technology, I am just learning this technology, mind it. So what are various types of nanomaterial? So that was the just introduction of the nanotechnology. Now we have carbon nanotube. It can be single wall carbon nanotube or multi-wall carbon nanotube or buckyball, as we have seen in the video, right? Single wall carbon nanotube is just like a hollow cylinder, and multi-wall carbon nanotube is one cylinder inside another cylinder, just like telescope arrangement, right? Then we have nanosilica, titanium dioxide, nanocomposites, and many more materials. So as I said, that single wall carbon nanotube and multi-wall carbon nanotube, buckyball or bucky paper. It is also known as graphene. Graphene arrangement is a C6 carbon hexagonal arrangement. In that video, that fellow has explained you that it can be arranged and make a sheet. So graphene sheet has lots of application in civil engineering, right from imparting strength to the material, for the purification of the water, sewage treatment, then groundwater contamination, and many things, right? So carbon nanotube is derived from graphene by arc discharge or chemical vapor deposition. We have seen these two methods in the earlier videos, right? A circular nanotube is called torus. Now this is amazing, that carbon nanotube's property. Now if we compare our young modulus, see what is of concrete, what is of steel, and what is of carbon nanotube. And tensile strength, steel is just 1 gigapascal, whereas carbon nanotube, you can see, can you believe, 150 times stronger than this. And as far as weight is concerned, it is almost 1/6. So what an amazing thing, that something which is even stronger than not 1 times, 2 times, but 150 times stronger, and weight. So we can have many more Burj Khalifa even at M20 concrete, right? With carbon nanotubes, right? So this is a comparison between single wall carbon nanotube and multi-wall carbon nanotube. So their length to diameter ratio, their thermal conductivity, right? So multi-wall carbon nanotube make incredibly stronger fibers, and the strength of multi-wall nanotube is 10 times higher than any other known fibers. So where CNTs are used, carbon nanotubes application in concrete is proven, right? And because the predominant that it is increased strength. So high performance concrete you can use with the addition of just 0.5% or 1% of carbon nanotube, right? But it is very costly also. CNT can be used in water purification. It is used in photovoltaic cells. It can be used to build bucky paper. So this is just an hypothetical cantilever with the use of carbon nanotube. You can imagine that is possible, right? Because it is 150 times stronger and 1/6 the weight, right? Now strength of nano-sized particles and graphene is amazing. Even you can create a bulletproof jacket and cut proof t-shirts. So I have video for that also. Let me show you. I hope video screen is visible.
Yes, sir. Yes, sir.
Okay.
Go on forever and ever and ever. Why am I still alive? When I believe any of these cuts could have led to serious bad injuries. And the reason is I wear a garment made of our own fabric. The garment is called Slash Pro. Slash is the clothing and the fabric we are using. It's all very, very young.
Boom, as you can see, I'm not cut at all. That's awesome. It's just red lines because I was pushing it so hard to cut through this short on my body, but as you can see, this short is stopped from cutting. That's amazing. Let's try this again.
Stay there, stay there, stay there. End of story.
Okay? Yeah. Very nice.
My screen is visible back.
Yes, sir.
Yeah, so that is the amazing power of the graphene or carbon nanotube arrangement. So you have cutless, right, bulletproof vest and cut resistant t-shirts and jackets, right? So that is there. Another very powerful material is nano titanium dioxide. It breaks down the organic pollutants. It is volatile organic compounds and bacterial membranes through powerful catalytic reactions, right? So nano titanium dioxide is widely used as a pigment because of its white brightness and excellent reflective coating and hydrophilic, and therefore gives self-cleaning properties, attracts water, and water is attracted, and whatever dirt is there, it carries along with it, right? So it can be used as anti-fogging coating, and it can also oxidize oxygen or organic materials, and therefore it is also added to paints. So I'll show you how it can be antibacterial. So any types of nitrogen oxides can readily react in the presence of the radiation, and it can stabilize it, right? So we need to understand this chemistry for application. Then further, it is air purifying. So any type of bacteria or any type of pollution, particularly NOx, nitrogen oxides or sulfur oxides, if they are present in the atmosphere, then this coating in the presence of the radiation, solar radiation, it becomes active catalytic and it absorbs like a magnet is attracting the iron piece, or if you have we all are civil engineers, so we know that when we add alum, how it makes coagulant. With the same principle, this nano titanium dioxide, when it is exposed to the solar radiation, it becomes active and it becomes the self-cleaning or air purifying. And this is the photograph of a church in Rome where this coating is already applied, right? Another application potential material is silica. Now silica is scaled down to nano level, and this has tremendous potential to change the concrete properties, as the hardening process is governed by the silica. The structure of the fundamental CHARUSAT gel, which is responsible for the mechanical and physical properties of the cement paste, so that is being affected by the nanosilica, right? So it can enhance the durability, it can enhance the strength. Another important material is fly ash. We all know that fly ash is a byproduct of the thermal power plant. Now if fly ash is converted at nano level, then also it has amazing properties. Now the question would arise in your mind that how we create materials at nano level. Grinding is one of the option, but grinding has a challenge that you need to grind it for a very prolonged duration, very large duration. A ball mill has to be run to make it nano. And further, when you open that mixer or ball, then everything will be fly away, because nanoparticles are very minute. So even when we are doing lab experiments with the cement in micron level, when we see it to 90 micron, what we observe that lots of dust is produced. So nanoparticles may wipe out. So there are other methods, chemical methods. As in earlier you have heard, there are two methods, right? Chemical vapor deposition and arc discharge method, and there are bottom up approach and top down approach. We as a civil engineer, we don't know much about this technology. We need to take help of the pure physics or applied physics people, so they can help us in deriving this nanomaterial or characterizing this nanomaterial, because we are least concerned how they are manufactured or how they are purity is, but we are concerned with that how we can apply to civil engineering field. Okay, so aerogel, this is another application where it becomes a very transparent, semi-transparent, and because of that light can be distributed very uniformly. That is another application, right? Further, insulation is against heating and light and noise, so that is also possible with this technology. And photovoltaic and foldable membrane, nowadays I think which mobile has come with the flap foldable, that is due to again nanotechnology, right? So solar panels can be made of this self-cleaning ability, right? So self-cleaning is that ability by which it becomes hydrophilic, and because when the water droplet comes on that, it just roll down, and along with whatever dirt is there, it is absorbed by the water and the surface becomes clean. So when you use this self-cleaning, you will save your material from efflorescences, from salt deposit or freeze thaw damage or acid attack, right? So that is the applications. So one tile is coated with self-cleaning material and rest of the tiles are not coated, and you can see the difference on left side, right side. So that is also a very powerful application of the nanotechnology. The principle how these scientists have invented this, again they were inspired by the nature. They see the lotus leaf and they found that water droplet is not absorbed by this leaf of lotus. So when they study, they found as the contact angle, right? This contact angle is less than 45. So if it is not there, then it will absorb. So if it is less than that, it will remain a water droplet, and this will flow directly. I have video for this also, but looking to the time, I can't show you all the videos, right? So we are going to the next. So self-cleaning paints, you might have seen a latest advertisement of Dhool Mitti, right? They are paper wrapping it, Asian paints, and even fans are available that Dhool Mitti tikega nahi, and they are just wiped out. Even when you go to petrol pump, few people come with that Teflon coating to your glass. They said it would be scratch resistance. So that is all nanotechnology directly. So water repellent glass. So these are some common applications, right? Even food packaging also, your food can remain fresher. We have seen that Tetra packing, right? So that is also application of the nanotechnology, foldable drives and TVs, right? Now we are, as a civil engineer, we are interested what are the application in our domain. So very first is that purification. So this is the basics of chemistry, right? We are not discussing that how van der Waals or strong bonds are there and how they react, right? So carbon nanotube, particular graphene, has this application. Let me show you. My new screen is visible?
Yes, sir.
Okay.
My job is to make college easier because students have a lot on their
New screen is visible, I guess, with audio?
Yes, sir. Yes.
So even fish dies in this water, and they have developed this nanofilter. And you can see TDS reduced. So in IIT Mumbai also, people are working on this principle. They have developed the glass. So nanotechnology has great application even in the sewage treatment or contamination of the groundwater, protect remediation of the contaminants from the groundwater, or even the effluent treatments. So water filter has a same application. Then we know that self-consolidating concrete application, that is also possible. Self-healing, this is again a very amazing application. Just see. So self-healing polymer, right?
business. Now,
so we are inspired by the nature and how our bones, when broken and kept in a stagnant condition, then after a month it gets healed. So the scientists are inspired by nature, and the same thing they are trying to replicate. So we know that microcapsules with calcium present in the concrete, when the crack is there, this capsule will burst, and this calcium will react with the moisture and it will make again the paste. Likewise, we are able to achieve the self-healing concrete. If it is cracked, it will crack by its own, right? So that way it is there. Similarly, light straw, nano house, and there are so much potential in concrete also. We have so much application. Along with the Internet of Things, you can monitor it, right? It can act as a fire coating also, right? So lots of cement based product are available. Nano concrete is one which gives high strength concrete. It can be self-healing, it can be self-sensing, it can be self-compacting, and because of the nanomaterial present, it can be bendable also. So at our university also, our master students are working, and we were able to develop the self-consolidating concrete, and we tried with the 0.3%, 0.1%, and 5% carbon nanotubes, and we procured carbon nanotube. It is very costly, around 40,000 rupees per kg, right? And we applied them in the concrete, and the results are amazing. That M20 grade of concrete, right, ordinary concrete, just converted to the M80 grade of concrete by inclusion of only just 0.5 percentage of the carbon nanotube. So you can see drastic increase. The reason being that the calcium silicate hydrate gel, it gets more strengthened because of the carbon nanotube. Further, why all durability issues occur? We know that more or less water or moisture is the root cause, whether it is alkali aggregate reaction, whether it is sulfate attack, whether it is chloride attack or corrosion. So again, in our lab, we thought that if we make the surface of concrete itself as hydrophobic, then these micro cracks and capillary pores, if they are sealed, we can protect. And we tried that with the nano titanium dioxide, and we did literature, and at our lab we did this thing, and we could get the hydrophobic concrete. So self-cleaning windows, this is how it works, we already discussed. So groundwater remediation, we have this nano zero valent ion, which is neither plus nor minus, so neither anode nor cathode, or anion nor cation, but it is a zero valence ion, and due to this, it has a very versatility to react with the, and it is a great absorbent, right? So literature paper says that this is the new material which is going to work as a good remediation source, just like alum, right? Nano iron powder is there. So when you inject nano iron powder, you can restrict this contaminant plume to move further into the segregated zone. It can be reacted as a permeable reactive barrier also. You fill this permeable reactive barrier with the nanomaterials, so contaminated water, when passed through this barrier, it will be treated. There can be injected slurry, so lots of groundwater remediation applications are also available. So now you all will be wondering that, okay, this FDP is about geotechnical engineering, and I'm talking of only nanotechnology and showing you lots of videos, right? But mind you, all these video will motivate you and will make you to think that how we can apply this technology to geotechnical engineering, right? So before we proceed, let me summarize what we have discussed. We have discussed what is nanotechnology. Nanotechnology is nothing but working at nano level, working or manipulating material at nano level so that our desired property we can achieve, whether it is a strength, whether it is transmissibility, whether it is conductivity, or any other desired property, maybe hydrophobicity, maybe hydrophilicity, whatever. We discussed about various nanomaterial, carbon nanotube, single wall, multi-wall carbon nanotube, graphene, torus, buckyball, bucky paper, nanosilica, nano lime, nano fly ash, nano titanium dioxide. We see different applications of nanotechnology in drugs, medicine. We see in concrete, it can be used for strength, it can be used for increasing durability. We see in groundwater remediation, right? So that's what we have learned up till now. So now let us move to the next section. So our first outcome that a learner will be able to understand what is nanotechnology and will learn about the properties of the nanomaterial. I guess that we have completed. Now we move to the next part. What is the application of nanotechnology in geotechnical engineering? Very limited literature is available, right? And in my mind, the concept came that after this potential of nanotechnology in medicine and other thing, it must have some great application in geotechnical engineering. So I think 7 years back, I started doing research in this field. So when concrete is getting amazing strength, high tensile strength, high ductility, self-healing and self-properting, why not geotechnical, right? So soil and rock are also, some of them are nanomaterial because soil particles are micron size, and if we crush them further, they can be lead to the nanomaterial, right? So nanotechnology can be used to improve the fundamental understanding of soil and rock, mechanical behavior, maybe friction, maybe creep rate effects, thermal effects, grain crushing, chemical effects, and it can be also used to predict behavior of the geomaterial under extreme condition, right? So nuclear waste disposable and other things are there. So this is the typical scale that we already worked at 100 nanometer, right? And this is the nanotechnology applications at macro level. So this is on left side, this is the application at the nano level. So definitely we can work, and nano geotechnical engineering would be the new emerging branch, just like geo environmental engineering, right? Geo earthquake engineering. So geo nanotechnology is the future, right? So the size range of categories of the soil particle, and various researchers have tried to use nano solutions along with the clay, and they have tried and developed amazing properties in the soil. So very first thing comes in the mind is the greatest challenge with the soil is particularly with the clay, because whenever we encounter clay, we found that either there is a swell shrinkage problem if it is of expansive nature, or if it is a very soft soil, then there are bearing capacity issues. If it is a clay soil and if nearby groundwater is there, then there is a consolidation issues. So one video which shows that if we use nano soil, then consolidation issues can be overcome. So let us see this video.
Meet the benefits of the modern road construction methods in order to convince yourself that the construction process can be cheaper, faster, and more environmentally friendly. In the beginning, traditional construction methods involved a huge mass of soil excavation and transportation. To that end, there is a large amount of heavy transport used, producing harmful exhaust gases, including CO2, that contributes to environmental degradation. Additionally, this kind of transport destroys the local roads, and there is no surface area for soil stockpiling. In fact, most of the soil does not have to be excavated or transported. The modern road construction methods effectively use the mass of soil in place and create a resistance to damage and a safe road base. While building the road base with traditional road construction methods, the same heavy transport is used to transport the excavated soil and to carry the precious aggregates, which are valuable natural resources built over hundreds of millions of years. However, there is a possibility for effective modification of existing native soil directly on the construction site, all through the process of modifying and hydrophobing gained by mixing specialist components and available soil in place. During this process, the changes in soil physical and chemical properties contribute to water deprivation and resistance to the destructive effect. As a result, there is a consistent and resistant to damage road base, exceeding even the highest aggregate quality. The day has come to put a modern road into use. During the construction process, there has been 7 times less heavy transport use, 4 times less construction machines employment, and 6 times less CO2 emission into the atmosphere. Moreover, there are no dump areas or destroyed roads, and over time and vibrations, the road base becomes even more durable. For comparison, the road building with the traditional road construction methods is not even 50% finished. The local roads are destroyed and blocked by heavy transport traffic, and regular vibrations contribute to decreasing the bearing capacity parameters. So why are the majority of roads built in this imperfect way? The implementation of the new soil modification technology for complete base creation of all road categories requires the order certification procedure and release from routine thinking on layered road construction. We have just started this ambitious process.
So just imagine that if we make soil hydrophobic, it will neither absorb moisture, so no swelling shrinkage problem, right? So I think you might be aware Zydek Industries near Baroda, right? So they have created one solution called Zycosoil, and that will literally, it is a hydrophobic soil. So when it becomes hydrophobic, you can see that the road would not be washed out, right? Can restrict seepage losses in canals significantly, no lining required. Failure of structure due to water movement can be avoided, for example, piping and other slip circle failure. Swelling nature of black cotton soil can be controlled. So huge potential is available, right? So let's see this. Just hold on. They have registered this patent way back 10 years, I guess. For this Zycosoil hydrophobicity material. They have made Zycoseal also, waterproofing agents. So how they are trying to develop these things, right? So just we are not expert, but with a little knowledge we can say that Mont Molonite minerals which have a swelling characteristics, right? They are attached with very poor bonding, right? So this material, because they have patented, they will not reveal what is done. I think in one of the paper they have discussed this. So by this chemical, what they are doing is they are making this bond very stronger, number one, so that it cannot be replaced by the water bonds, right? And another thing is this water repellency. So they have coated so that whenever water drop is there, their contact angle is less, right? So with this, that is possible, right? So at our university, my students are working in controlling the swelling characteristic of the black cotton soil. So in our backyard, we have black cotton soil. So we have tried with the fly ash, we have tried with the nano lime, we have tried with the multi-wall carbon nanotube. We are working with the nano silica, and we are also trying the best combination, right? So thanks to our physics faculties, Dr. David True, we were able to do a joint research, and with his help we could derive nano lime. So traditionally we thought of that when black cotton soil, when treated with the fly ash and lime, reaches to the very stable configuration. So we thought of why to not apply nano lime, and whether nano lime has the same potential, it can result in a very high strong, or it can result in a negative way also. So we did the research, and we tried and developed the nano lime. I am not expert of this XRD and fluorescent emission microscope, but I can at least tell you that whatever we have manufactured in our lab, right, that was of the nano level, right? So these particles, you can see this much size is 200 nanometer, right? So diameter and thickness, you can see there are some needle like things. So that is there. So that is a nano level of lime is produced. And when one of our MTech student was given this task to work with the nano material, black cotton soil, 60% fly ash, 1% nano lime, 0.5% nano lime, and 0.25% nano lime. Similarly, we have produced nano fly ash, again with that all help also, and we could also get nano fly ash also, right? And then we have tried various combination, and this is the result of the 80% black cotton soil, 20% fly ash, and 0.5% nano lime. And you can see that liquid limit is reduced drastically. Shrinkage limit also has reduced. So free swell index also we have tried with the various combination, right? So 60%, 40% fly ash, and 1% nano lime. We can see that free swell index was 0, right? So that is the power of nano things. Otherwise, traditionally you need to add 12% to 15% to lime, but while converting it to the nano level, only 1% is sufficient, right? So that is the power of the nanotechnology. Likewise, unconfined compressive strength was also performed on the various specimens, and we found that unconfined compressive strength was also drastically increased, right? So that is the area we are working. Then we found that no researchers were working with the carbon nanotube because carbon nanotube is very costly, but carbon nanotube is imparting great strength into the concrete material because of the CSH gel modification. So we had attempted to see the effect of multi-wall carbon nanotube in black cotton soil, bentonite also. I have not quoted all the results because that research is still going on. But when we added 0.25% by weight and 0.5% by weight, not much difference is found. So we can say that carbon nanotube has not that much effect. You can see liquid limit is almost remaining same. Plastic limit also same. Shrinkage limit we could not find out. Soil type is also more or less remains same. And because of the light weight, the specific gravity is reduced and unconfined compressive strength increases, right? So likewise, we are trying to work, and that work is going on. OMC MDD we have tried with the black cotton and bentonite soil also. Another work, nano fly ash, nano lime, and that work is still going on. So that research is going on. So in summary, we can say that when we want to conclude that nanotechnology is a versatile technology which has diverse fields of application. It has a good outcome is that it can obtain strength and conductivity for cement concrete, but durability aspect is yet to be researched. In concrete, what we have found is majority people have worked with the strength, but very less work is found in the durability for nanomolded materials. Now nanomaterials have lots of application in paints and other things. So geotechnical also it has lots of application, particularly in geo-environment field for remediating pollutants. And very few research work is done in for case of the improvement of the CBR or hydrophobic soil application. Only this Zycosil and other few papers you will found. So lots of scope is available in working in this area. And from our work, what we have done, then we can say that 20% fly ash and 0.5% nanolime and 28 days of curing has a good effect to control the swelling characteristic. And carbon nanotube applications are not promising. One danger associated with the use of nanotechnology is that it can always we need to study the toxicity or the environmental ill effects of this technology, because one has to be very careful while working nanometer because it can readily inhale, particularly carbon nanotube. And so lots of safety precautions you need to take, as well as when we are applying for remediation process, right, or stabilization process, then the leachate should not contaminate the groundwater. So these are the concluding remarks that nanotechnology has great potential, but still I think it is in a research phase. Cost is also very high. Plus we don't have sophisticated instrumentation like SEM and TSEM. So we rely upon center of excellence where these sophisticated instruments are available. So we do experiment here, we take sample and we send them for the laboratory. Then it would take 1 month or so, and then we'll get the result and then we analyze. So funding is also another challenge when you want to work in this, but of course, huge potential is there for this technology, right? So with this, I stop my presentation and invite the question answers in this. Thank you.
Sir? Sir, we are
Yes.
having some questions in the chat box. First question, can I read it up for you?
Yeah, I can't see. Do I need to change?
No, sir, I will read it for you.
Okay.
The question is, what is the effect of nanomaterial over a long run on the soil or the groundwater or the substructure?
Yeah, that is the durability effect. Over the long run means the durability effect. Now there are lots of varieties of the nanomaterial. So over the passage, the nanomaterial will remain its dimension, but whether it's contaminant effect or your swelling characteristic, if you are talking, so it remains same. But of course, from environmental perspective, one must study the ill effects of the nanomaterial, and to check whether in the long term their effect are consistent or not. Then of course one need to study durability studies or accelerated durability studies, and that is in the research phase. Still it has not been revealed, but in my opinion, whatever little I know, I think their effects are permanent. It should be permanent.
Yes, sir. In that line of connection, I have one question. Sir, is there any example of practical applicability of this nanotechnology in civil engineering point of view?
Many application. I told you there are Jubilee Church in the Rome. It is there readily available with the nanotechnology, nano titanium dioxide coating. Asian paints are having this Teflon coating. Then Samsung has used this silver nanotechnology. Cosmetic tubes are coming there. So in civil engineering practice, in India it has not came yet, but in European countries it is very well established. Ultra ever dry paint, it is already patented and available commercially, right? So you can coat your urinals and washrooms, and you can save a lot of water, right?
Any IS code available in this regard?
No,
for
not
this
yet.
practice, IS code or any other international codes, if it available?
International code, maybe we need to explore, because it is in the research phase little bit, right? So no specific codal guidelines are available to add it in concrete or to add it in the soil, right? Just like fly ash, now some guidelines, or geosynthetic, some guidelines are available. So for nanomaterial, as of now, there are no such guidelines available.
I guess much scope is there of using nanotechnology in ground improvement techniques, especially.
Huge scope is available. Even not only in ground improvement, but structural health monitoring also. For example, we are doing pile integrity test. So if we add carbon nanotube into the pile itself, then in your mobile only you can get the integrity results by use of Internet of Things, right? So that sort of applications will come up in near future. You explore in YouTube that how these self-sensing applications are available for nanotechnology, that is known as piezoelectric sensors. So generally what happens when material is loaded, it is get deformed. So this carbon nanotube and other they are known as piezoresistive material. So when they are stressed and when they are bent, they generate minute current. And when we keep our LVDT nearby that, so they will sense that current, and we do reverse calibration that, okay, for 1 mm deformation, what is the bending stress and what is the current generated. So if we make a chart and if we train an algorithm, then directly we get the reading that, okay, it has deformed 1 degree, so this much current is generated. So we can say that, okay, tilted 1. Lots of applications.
Sir, one more question we are having. How will nanomaterial react during the elevated temperature or the pressure condition, especially if they are used in the deep excavation related work?
At elevated temperatures
or the pressure conditions.
In pressure condition. Okay. So I guess nanomaterial application with high temperature or pressure, that research work I have not came across till date. So that is interesting to study, because I have not came across such things till this point. But that would be an interesting thing to learn, because at high temperature generally materials conductivity and pressure resistance is in question. So at high temperature, probably whether material continues its physical form or not, that is again a need to be studied. But in deep excavation, your insight is that when we excavate deep and when you want to apply nanomaterial, so for which application, whether to protect soil boring or to protect the diaphragm wall, that would be the another things to know, right? So I think that those studies still are not done. So I would not be able to answer that. What is the exact effect?
Yes, sir. Sir, one more question I just wanted to ask. You have shown the study which has been done by your student. So while doing that study, what was the cost that is, he has used the 1% of nanotubes in that. So what was the cost during this project?
We're talking of cost is very high for carbon nanotube. That cost for 1 kg of carbon nanotube material, you require 40,000 rupees, right? So carbon nanotube you can skip for the cost point of view. In concrete, it has a great application, but in soil, from our study, we found that it has no application, right? So you should not invest that in soil. But other people who are working in the physics department, they can help you out, and they can. We civil engineer don't have the knowledge that how to create a material at nano level. But if you do multidisciplinary work, and if you just take little help of your physics faculties or nanotechnology faculties, for them it's very easy. It's like for us, we are sieving the soil. So they will also play some chemistry, right? They will do 2 or 3 heating, adding one chemical, then magnetic stirrer, and then stagnant, primary sedimentation, secondary sedimentation, and third day your nanomaterial is ready. So it is very easy for them. So you can directly get nanocarbon instead of carbon nanomaterial. That is very economical substitute to carbon nanotube, and it has the same equivalent properties.
So much scope of work is there, especially in regard of cost optimization.
Correct.
Especially the interdisciplinary research. It is. I think I can see the huge scope is there in this space. Okay, geotechnical engineering with the nanotechnology.
Sir, I just wanted to ask, currently in India, how much work has been done in this particular area?
In India, if I talk of geotechnical engineering, then I would say very rare. Very few people I have seen working in geotechnical engineering. I think I found one lecture of Professor Siva Kumar Babu, and IIT Bombay, TI Eldo sir is working, and then probably at DDIT few people are working, and at our university, and at DDIT also the person who is working is our research fellow. So very less research work is going on in field of geotechnical engineering, but of course in structural engineering people are working to improve the strength and durability, high strength concrete, it is there.
Sir, one more question we are having. As of now, which nanomaterial are restricted to use in soil application?
Restricted? There is no such restriction. I mean, the field is open. If you found any toxic or hazard effect which is harmful for the people, you can restrict. Otherwise, you can use nano lime, nano fly ash, nano silica, and any material can be converted to the nano soil itself. We can convert, right? So huge applications are available. Still, this area is not churned out, so you can churn out and you can publish very good research paper within a short time.
Anyone from audience, if
I think
participants?
South Anjum.
Yes. South Anjum, if you want to ask, you can unmute yourself.
If anyone wish to interact with the expert, they can just raise their hand so that we can enable you to speak. Yes, one participant is there.
Srinivas sir, yes, you can unmute yourself.
Good afternoon, Dr. Siddharth and organizers, participants. Wonderful lecture. I was actually patiently hearing to your lecture and the videos you have shown. Excellent. And the first and foremost point is I would like to compliment you for this excellent. You might have spent hours together, to prepare this presentation.
Thank you.
Okay, collect all the material, videos, collate them and all. Wonderful. Very nicely you have done that. Thank you for that. And my only specific question is, pertaining to geotechnical engineering. Like, you said there's a cost involved in working with this. What kind of what kind of basic instrumentation is required, or directly we have to sit with the physics department faculty and move forward?
Sir, good question. Actually, I am also learning this thing. I am not the expert. I am also just like you, because I was just inspired by one person who was working in structure, and when I attended an FDP like this, then I jumped into this research field. So your question is that what instrumentation is required if you want to explore nanotechnology material and nanotechnology applications in civil or geotechnical engineering?
Geotechnical in particular, yes.
But yes, sir. So there are two things. One, that because this nanotechnology is working at nano level, so whatever things you add, right, addition is very easy. For example, addition of nanofly ash in soil is very easy, and you can do liquid limit, plastic limit, unconfined, and blah 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 test. But then why those effects have been occurred? For example, liquid limit reduced, why it reduced? So for that you need to study its microstructure, and to study that microstructure we need to learn that what is this microstructure, because what are these parameters, and for that you require some powerful instrumentation, scanning electron microscope. So that facility either you should have at your own, or you can give it to third party. For example, CSIR is there, Central Salt and Marine in our Gujarat. We have several center of excellence for nanotechnology. At Nadiad is there, at IIT Gandhinagar is there, at Bhavnagar is there. So maybe from the state where you belong, there must be some good institution where these kind of facilities are available. So what you can do is you can do this work, and then you can send your sample to them, and they will give you result back. And to understand this nano material, whether they are really nano or not, you will be required helping from your physics faculties.
Well, please.
I hope you are satisfied.
Yeah, I am. But the point is, you mentioned some other speaker asked you, some other listener asked you, right, regarding portal provisions and all. Now I'm intrigued by that point. Like, are these processes well established, or is all ad hoc, or like you said, mixing, right? So mixing, like what? It's in a mixer, the hand mixing or the machine mixing, or you need a stirrer for that, or I mean, I was just looking into the the nitty-gritties, the actual execution of the process in the laboratory. I was curious about that.
Yes, that is a very good question, sir, because we tried everything. We did it dry mixing, we did wet mixing, we mixed in stirrer also, because few research paper, by referring few research paper, they will not reveal exactly how they have done this work. So we did it by trial and error, and which type of nanomaterial you are working, it depends upon that. For example, nano titanium dioxide we wanted to use in soil, right? So nanotitanium dioxide itself is hydrophobic. So we can't mix it with the water. When we mix it with the soil and when we tried to do the liquid limit, it was not workable because it was not mixing at all, right? So we can't perform liquid limit test. So we again consult to the physics people that, okay, please help in this matter. So they did that. You add raw solution of final product is nanotitanium dioxide. So you add semi product which is in a liquid form. We added that into the soil. So for carbon nanotube, it was added in a dry way. So right now, because the very less research work is available, so there are no established guidelines or specific needs, specific guidelines available that, okay, you do dry mixing, you do wet mixing, you mix it in a magnetic stirrer, or you mix in a mixer. So that is all up to you, right? You can do trial and error.
I totally agree with you with the point which you mentioned. Research is mostly in the beginning, it's trial and error, correct? Then you hit upon that eureka moment, but then I totally agree with you on that. But then having said that, the only problem remains is, soil and water are inseparable, right? We've been learning it. So when you add titanium dioxide and it is doesn't like water, water and soil are they're inseparable. So we can't think of soil without water.
So soil has become hydrophobic. I show you one video, this Zyco soil.
You
made this solution and they have made it hydrophobic.
The
now,
pavement.
Because they have patented, they are not revealing. But little I know that silane is a term. Even I am studying it. I am not master of this topic. Let me confess that I'm still learning. But silane is that terminology which they use. So with the help of silane, it is possible.
How do you pronounce it? How do you spell it rather? S-A-L-I-N-E?
S-I-L-A-N-E, silane.
Oh, okay.
So if you meet with any physics people, it's very easy for them. It is difficult
I'll
for
catch
us.
up with them. I'll catch up with them. Something interdisciplinary is required these days. Thank you. Thank you for your patient answering to these questions. Thank you so much.
My pleasure, sir. My pleasure.
Thank you.
Thank you.
Sir, additionally, I just wanted to ask the thing that, okay, we have talked about the mixing techniques. Okay, so after a trial and error method, the mixing technique has been finalized. But how we are finalizing that the nanomaterial has been evenly or the homogeneously, it has covered all the soil particles. So how we are verifying these things?
Correct. So again, we generally see whether it is a uniform color achieved or not. That is the very preliminary thing. Okay, when we are doing it dry mixing, right? For example, you are adding white powder with a grape brown powder. So when you mix it, visibly you can see whether it has uniformly mixed or not. Right? That is a simple thing. But it is very important a nanomaterial to disperse or mix thoroughly with the raw sample which we have taken. So visual observation is the only thing right now available. Second thing, when we are doing wet mixing, it guarantees that when you mix it, gauging time, when you say for 2 minutes, definitely it will ensure that it has mixed uniformly. So when you are doing dry mixing, you can visually see the color, and when you are doing the wet mixing, you should mix it for at least 2 minutes. So I'm sure it will mix thoroughly.
Sir, I have one more question. Just one question comes in my mind when you will interact with the Srinivas sir. Sir, when we will try to coat the soil particles with the nanomaterials, won't it affect the frictional behavior or the angle of internal friction? What I'm saying, space. Won't it get reduced?
Depends upon what type of soil and what type of nanomaterial we are adding. So, for example, if you are taking a clay soil and when you are trying to add it with the carbon nanotube, for example, so clay soil has a strong cohesion, right? So you just work out with the triaxial UU test and you see whether your cohesion value has increased or not, right? Then comes whether it has increased or decreased. Then comes the microstructure study, that okay, increase, then why it has increased. So again, you need to see that where is carbon nanotube, where is your clay particle, what is the interaction between them, because it is still in research phase. So we cannot accurately say that okay, the blah bond has changed or XYZ thing. For concrete, it has been established that okay, there is a CSH bond and bond is strength is increased or something like that. But in soil, it has not been established, so we will establish. So very good thought that okay, if it is angle of internal friction, now angle of internal friction directly changes with the amount of overburden or normal stress. So that is again, so by adding nanomaterial, if we add some interlocking thing, then it can increase, right? So from that point of view, one application is still in my mind, that when we are making concrete self-consolidating, why can't we make soil self-consolidating? Imagine no question of OMC MDD. Just you spread this nanomaterial, no roller required, no water tanker required, everywhere road will be very good, right? So that is also a research field open. That is the thing I came in my mind, right? It is there.
Thank you, sir.
So one more question we are having. What about the material deterioration after it has been treated? For example, cement is treated with the nanomaterial. So is there any study that say that say about some frame time regarding the deterioration in the material or the damage in the material?
Wear and tear effect and abrasion effect, that is not studied yet, because yet the application are is for potential application are there for enhancing the property, yet durability studies and all these studies I have not came across. So I don't know, I would say.
So one more question we are having by Rafi. He is asking that is it should be only used for the soil or any other material like fly ash, mine waste, or we can use this nanomaterial techniques in that also?
I'm not getting the question. Can you repeat?
Is it should be used only for the soil or any other materials like fly ash or the mine waste?
Okay, to stabilize mine waste or fly ash, that is your question. Can we apply nanotechnology to soil, or can we apply it to other waste also? You can apply it to other waste. Again, you need to study chemistry. Okay, which nanomaterial will fit and what parameter you want to stabilize. You want to stabilize slope. You want to stabilize some chemical carcinogenic action. For example, chromium waste, chromium 6 is dangerous. So by applying chemistry and nanomaterial, you can stabilize it to the chromium 3, which is more stable. So what application you want to target? You want to stabilize chemically, you want to stabilize mechanically, and my answer in brief is yes, you can apply.
Anyone?
Dr. Siddharth, it's not a question from my side. It's a kind of appreciation from my side, not a question. Like the kind of the number of questions your presentation has generated. It has generated quite a good amount of interest in this. So the number of questions asked in your presentation is, an indicator of the extent of interest you have created in the audience. Thank you.
Thank you. Thank you, sir. Thank you.
As such, I am seeing no any questions in the chat box. Sir, from on behalf of all the participants and as well as myself personally, I have seen this session was more interesting and very informative because it has enlightened the spark in us regarding one new emerging area in our geotechnical engineering. And Just in general, I want to inform you that in our campus also, we are also having a well-established instrumentation. So we will also try to find out some studies, and we will try to grab some of the informations, and further we will also contact you so that we can also
Anytime.
we can
I'll be
also
happy to
develop our
help.
interest in this area particularly.
And I was part of CHARUSAT also in 2007.
Great,
Yes,
sir.
sir. Yes,
8-9.
yes, sir. So then you must be aware about PDPS department.
Yes, yes.
Yes,
Okay,
sir.
so we can try to establish new laboratory for the nanotechnology in PDPS Institute, especially.
Great.
Okay,
Professor
where the
Sumesh is
collaborative
there
research
or
work can
not?
be done. Yes.
PK Sumesh.
Yes,
Professor
yes,
Sumesh.
yes.
So
He is
he
there.
will
He is
help
there.
you.
Yes, yes. He's Dean of Faculty of Science and Technology.
Oh, great. Great to know that.
Thank you.
Thank you, sir. The session was very informative, and the questions which we have took up from the audience that shows that lots of audience are interested in this particular area. So surely we will also contact you to take up this particular session to the advanced level, so that we can also enhance our broader studies in this particular area.
So
Thank you, sir.
thank you all for patient hearing, and definitely you can contact me. I have shared my details. So if you have any doubt or need any help, I will be happy to help you. Thank you.
Sir, one more request. The
Yes.
videos which you have shown during the session, can you
Yeah.
share the links?
I will share the link, all the links I will share. I will send my presentation also in PDF format. Okay.
Sure, sure, sir.
Sure.
Thank you.
Thank you, sir.
Thank you. Thank you all.